All right, so today is a two-day lesson. So day one, we are factoring polynomials. So our essential question for today is, how do I know if a binomial is a factor of a polynomial? And how do I factor by grouping? So we're going to do two things.
So who uses this? Well, ecologists may use factoring polynomials to determine when species might become extinct.
Oh.
Isn't that weird? But it's true. Okay, so look at this remainder theorem. Basically, what we're going to be asking you is a couple things. Number one, we're going to ask you, is the binomial a factor of the polynomial? So think about it. Let's talk about two numbers. We say, is 6 a factor of 24?
Yeah, because 6 times 4 gives us exactly 24.
Right. So 6 goes into 24 evenly with no remainder.
Right.
So when we use synthetic division to divide a binomial into a polynomial, and the remainder is 0, that means it is a factor.
Because there's nothing left over.
Correct.
Okay.
But now, before we go on to that though, we're going to do something else. Notice on example 1, we're going to use synthetic division to divide, and it's asking us, what is p of -3? All that's saying is, if we would plug in a -3 into the dividend, what answer would we get? Okay. And so what we're going to actually do right now is we're going to divide, and the remainder is that value.
Okay.
Okay? So here we go. We're going to use synthetic division to divide. So number one, we have a little problem here though, Miss Boyd, because it's not. What is that?
I don't know.
It's not in standard form.
No, so I'm going to write it in standard form.
X cubed plus 3x squared plus 0x plus 4.
All right.
So let's bring down our coefficients. A 3, a 0, and a 4. And what goes in the upside down division sign?
-3.
Awesome.
And, all right.
Bring down the
Bring
1.
down the first one. And we have 1. 1 times -3 is -3.
Add.
3 plus a -3 gives me 0.
Yes.
-3 times 0 is 0.
Add.
Oh boy.
And multiply. And bring down the 4.
Okay.
So what is it asking us to do? It's not saying write it. We're not dividing to find a quotient here. It's saying use synthetic division, but then what is p of -3? So maybe let's write that p and then -3. Remember what I said that's equal to?
4.
The remainder. Correct. We're evaluating. Basically what we're doing is evaluating the function when x is -3. A shortcut way is to use synthetic division.
Okay.
That's it. Let's go on. I'm going to scroll to the next page. Okay, here's the factor theorem. I kind of jumped ahead in a screen before. I apologize for that. And the factor theorem basically states if you use synthetic division, your remainder is 0, then the divisor is a factor of the dividend. Okay?
Got it.
Or the polynomial here. Here we go. Let's go.
We'll try it.
So we have to use synthetic division.
All right.
It's in standard form.
It's in standard. So I'm just going to bring down my numbers. I got a 1, a -3, and a 1.
And what goes in the upside down division sign?
-1.
Correct.
Add, bring down my 1. So I have 1. -1 times 1 is -1. Add them, I get -4. -1 times -4 is a +4.
Add them,
I get 5.
So right now, do we have a remainder?
Yes.
So guess what? It says determine whether the given binomial is a factor of the polynomial. The answer is no.
It's not a factor because it doesn't have a 0 there.
Right, because the remainder is 5. The remainder has to be 0.
Okay.
Let's go to the next one. Example 3. What do you think? Should we do this? Let's do it.
Yeah,
What the heck? We've had a lot of short videos.
3x to the 4th
plus 6x cubed plus 0x squared minus 5x minus 10.
All right, so we have
3, 6, 0,
-5,
and -10, and the upside down division sign is a -2. Bring down the 3.
3
and
times
multiply.
-2 is 6. -6.
Add.
0.
Multiply.
0.
Add.
0.
Multiply.
0.
Add.
-5.
Good. I was trying to trick Miss Boyd to see if she'd say 0.
Ooh, -10 plus 10 is 0.
The remainder is? Yes, it is a factor.
All right.
We get so excited about math. All right, here we go. Now, this is the second part of day 1. We are going to factor. I know you guys love to factor, so that's why we threw this back in here for you. So, the steps we're going to follow when factoring by grouping. Number 1, group your terms. Number 2, you're going to factor the greatest common factor from each group.
Whatever else.
Then you're going to factor out the common binomial,
Okay.
factor the difference of squares. I know that's a lot of words, so let's do an
it.
example. Here we go. Example number 4. So when I say group terms, this is what I mean. Number 1, is it in standard form, Miss Boyd?
Yes.
Okay. And now when you're factoring by grouping, you don't need a zero coefficient. That's only with division.
Okay.
So what I mean is I'm going to actually have you rewrite this for me because I'm really picky about this.
Okay.
So do a parenthesis, then x cubed plus 3x squared. Do another parenthesis and do a plus sign. And then in parentheses, negative. Do you see kind of what, I'm sure you probably do the same thing, but I know those negatives just throw students, and that's our grouping. Now, step 2, factor the greatest common factor out of each one.
Both of these, x squared.
Yeah, and we've already done this. When a is greater than 1, they know how to do this. Plus 3. And over here, plus now,
let's take the negative
you
out.
have to. If the leading term is a negative, you have to take out a negative.
So negative 4 over
X plus 3.
Plus 3.
It has to be the same.
And we did it right because these are the same.
Now,
So
we have 2x plus 3. Let's factor 1 out.
Okay.
What's left over is?
X squared plus, oh no, minus 4.
Yeah. Right?
Ooh, and that's a perfect.
So write that in parentheses. Now wait, it says factor the difference of squares if you can. So x plus 3 comes down.
Oh, yeah, bring it down. So we have x plus 3. And now we've got an x
plus 2 and an x minus 2. You're going to get so comfortable with this, you're going to be able to do that. But now, I don't think we're done.
No, we got to set them all equal to 0.
Yep, so x plus 3 equal to 0. X plus 2 equal to 0. Or okay.
Sorry, I'm just finishing it right
And you
away.
know what? You can do that because you're doing all the writing. That is a negative 3.
X plus 2 equals 0. Subtract 2.
2.
So x equals negative 2.
Right.
And x minus 2 equals 0.
Add the 2.
Add 2. So x equals 2.
We have
So,
3 roots.
Negative 3. We have
negative 2.
And we have 2.
Now, I'm going to say something right now.
Yes.
What is the degree of this polynomial?
Of this one?
Yeah.
It's to the third.
It's 3.
So it's cubic.
Right.
Oh, so you should have 3 answers.
Yes, that's what I'm saying. If the degree is 3, you better have 3 roots. If the degree is 2, you better have 2 roots.
Got it.
Got it?
Okay.
Okay, so I'm going to scroll down for Miss Boyd here. And example 5, we are going to do, what do you think? This is it. Do you want to do
Let's just
should
do
we,
it in class.
let's do that. I think the students like that when we do that. Okay. Look at this.
All right.
Factor the expression and find the roots. Factor by grouping. And then determine whether the given binomial is a factor. So on this one, you're going to use synthetic division.
Yes.
See you tomorrow.